The following video is all about problem solving 2, extending unit analysis. So we're going to build upon what we did in the last lecture, extending unit analysis, and we're going to look at a couple more examples that allow us to do some conversions, and we're going to look at some further rates. So we talked about rates in the last section when we were doing conversion of miles per minute to feet per second. This rate is something that has a comparison of one unit over another unit. And so there's more than one way to have to convert units that are in rates. Of course, distance over time is the most common one. We're going to look at some other ones in this section, and then we'll put it all together and we'll do a couple more examples to wrap up chapter two's work. So let's see what we got. Again, the objectives are similar to the first one. This chapter 2A, 2B is really, these two units really could have kind of blended together into one really long unit, but they just kind of broke up the different style of problems into two separate sections. The exam, you're not going to know one came from 2A and one came from 2B. It's just a matter of being comfortable with converting all the different types of problems that you can see. And so, as I mentioned, we want to talk about some of these rates and different units that are related to one another also. And so the first set that we're looking at is units of density and concentration, right? So how compact or how crowded something is. These are also rates in a way because they're giving us one unit over another unit. And so material density, like how dense an object is, we express the numerator in mass and we express the denominator in volume. Population density, which we're going to look at in an example today, is the population amount of number of people in a particular area, right? Obviously, if there's lots of people living in a particular area, then you're going to have a large number in population density. If people are spread out, then the population density will be very small. And then lastly, information density. That's like how big a computer chip is. It's mass over units of volume. Apparently, gigabytes are or megabytes or any of those are volume measurements. I didn't know that until now. But information density can give you how much mass is in a particular area. So the first example that we have actually goes back to something that we were doing in the previous section. We want to make a conversion between centimeters and inches. And so in this one, it tells us that we want to convert 800 centimeters squared into inches squared. Well, we need to know a conversion first. So on your own, I'd like you to work on this, but while I write down the conversion that we're going to need for this problem. So we found that the conversion that we need in this problem, and again, on a quiz or a test, these conversions would always be given to you in the problem. We find the relationship that 1 inch is equal to 2.54 centimeters. And we're asked to convert 800 centimeters squared into inches squared. And so what we're going to do is we're going to start by writing out 800 centimeters squared, which is the value that we were given in the beginning. Again, this one isn't a rate, so we can express it as a fraction over 1. We're going to multiply by another fraction here. And that's going to give us the conversion that we were looking for before. The inches go into centimeters. Now, we know that we have centimeters on the top here, centimeters squared, in fact. And so to balance that out, we're going to need to put our centimeters down here so that those units cancel out. So the way that we're going to use this relationship in the fraction is by putting 1 inch on the top and 2.54 centimeters on the bottom. Now, unfortunately, these would not cancel yet because here I have a centimeter squared and here I have a single centimeter. So what we have to do is actually raise both of these to the second power in order to get those units to line up. Then once I do that, I'm ready to go ahead and cancel. My centimeters squared unit is going to cancel with a centimeter squared. Don't forget that you're squaring 2.54 as well. And so when we multiply across, I'm going to have 800 times 1 squared, which is just 800. And on the bottom, I'm going to have 1 times 2.54 squared. Again, don't forget that that square also goes to the 2.54. Some people like to do that conversion first, Some people like to do it last. You can see that I waited to do 2.54 squared to the very end. My centimeter squared units canceled out, and so the only unit that I have left is inches squared, which is what I want. And so I'm going to divide these in order to get a simple form of that. And I get about 124 inches squared. On we go. The next question says, suppose a dose of 9,000 units per kilogram of penicillin is prescribed every 6 hours for treatment for a bacterial infection. For penicillin, 400,000 units is equal to 250 milligrams. So there's a relationship right there that we're going to write out to start. We know 400,000 milligrams is equal to 400,000 units is equal to 250 milligrams. And it says a dose is 9,000 units per kilogram. The first question asks us to express the dose in milligrams per kilogram of body weight. And so for that, we start with the dose. Again, the dose is in so we know to begin that our dose is 9,000 units per kilogram. I'm going to start with writing out my 9,000 units over 1 kg. Then I'm going to multiply that in order to get it in the dose, which is milligrams per kilogram. I need to have a relationship between units and milligram, which I do. I want my units to cancel out, and I want my final answer to have milligrams on top and kilograms on the bottom. So I'm going to write 250 milligrams on top, 400,000 units on the bottom, and that allows my unit to cancel out. Now I'm going to multiply across. In the top, I'm doing 9,000 times 250. And on the bottom, I'm doing 1 times 400,000. So I have 2.25 million over 400,000. And I get 5.625. My unit is milligrams per kilogram. And then there's a follow-up question here that says, how many milligrams of penicillin would a 20 kilogram child take in one day? Remember that this amount that's prescribed, this 9,000 units that we mentioned before, is every 6 hours. So you need to keep that in mind. At the end, when we get our answer, remember that that answer is only going to last, that medicine's only going to last for 6 hours. So we're going to have to multiply that by 4 in order to turn it into one day. We want to know how much to give them over 24 hours. So let's start with our answer that we got last time, 5.625 milligrams over kilograms. So this is the relationship between how much medicine I'm giving them in milligrams based on how much they weigh. Obviously, the more they weigh, the more medicine you give them. This particular child weighs 20 kilograms. There's not a unit here. I would just write this over 1. Remember that your final answer should be in milligrams. Right now, if we multiply these across, my kilograms cancel out, and I get my answer in milligrams, which is what I'm looking for. When I multiply this out, I have 5.625 times 20, which is 112.5 milligrams. Now remember, this is for 6 hours. And so we want to multiply that by 4 in order to find out for 24 hours. 112.5 milligrams times 4 doses gives us 450 milligrams for 24 hours. And on we go. We have one last example that deals with population density. And it asks, which has more people? County A, with an area of 192 square miles and a population density of 64 people per square kilometer, or is it country B? Country B has an area of 64 kilometers squared and a population density of 192 people per square mile. So, pull up the problems first. So in this third one, we have the issue that one of them is given to us in miles squared. The area is given to us in miles squared and the density is in kilometers squared. And then the other one is the opposite way. So we need to convert these and make them the same. I think the best way of handling that would probably be to convert the first one. Of course, we need to know a relationship between miles and kilometers. So before we do anything, we need to first find that value. So it turns out that there is a relationship that 1 mile is equal to 1.609 kilometers. So we're going to use that in order to make a conversion between square miles and square kilometers. For each one of these, for County A and for County B, our goal is to get our answer in people. So keep that in mind as you're doing your unit analysis. We're going to start with County A. We know that County A has 192 square miles. We also know the population density. I'm going to put the number on the top, 64 people over kilometers squared. Now, right now, when I put these together, nothing cancels out. Miles squared doesn't cancel out with kilometers squared. If these were the same unit, this would be great. We would knock this problem out really quick. But like I mentioned, we need this conversion. So what we're going to do is we're going to make another multiplication here. And remember, our answer that we want at the end is going to be in people. So we want miles squared to cancel out, and we want kilometers squared to cancel out. So what I'm going to do is I'm going to put my mile on the bottom. I'm going to put my kilometer on the top. And don't forget, because we're talking about area, we need to square both of those values. When we do that, you can see that our square kilometers will cancel with the one on the bottom. Our miles squared will cancel with the miles squared we're using in our conversion. And whatever we get at the end will be an answer in people. So if we multiply, I'm going to multiply 192 times 1.609 squared. And I got about 497 people. Now we're going to do County B in the same way. County B, we have 64 square kilometers. We get our 192 people over miles squared. We multiply by the conversion. Now be careful, because now we have things flipped around. So our unit fraction that we used before, our conversion factor, is going to be flipped over. We want kilometers squared on the bottom. And we want our 1 mile on the top. This time when we multiply, again, our units cancel. Kilometers squared cancels, miles squared cancels. Our answer's in people again. On the top, we multiply 64 times 192. And then we're going to divide that number. 12,288 over 1.609 squared. Gives us about 4,746 people. And so we can see that County B in this case, once we converted them into the same unit of people, that County B is much, much larger than County A. So that's it for our examples. When you go through and you do your homework, you can follow along with these videos in real time because it'll help you with the examples in your homework. Many of the problems from here were taken from there. So if you run into something and you may be stumped, go back and check out these videos and see if they help. And of course, reach out if you have questions.